So the previous day we learned how to solve quadratic equations by isolating for your variable. Now we were able to do that because there was only one x that we had to isolate for because it was in the bracket. If you have an expression like the following, 4x squared minus 2x equals 0, we have an x squared term and an x term. We can't actually isolate for it. So we need a different method, and that method is going to be factoring. Before we get to factoring, though, we're going to consider the following example, negative 2x times 3x plus 2. That's what brackets mean, multiplication. And we want to simplify. So we're going to go back to grade 9, and we're going to distribute that negative 2x into our bracket. So when we do that, we end up with negative 2x times 3x. So we multiply the coefficients to get negative 6, and then x times x is x squared. Negative 2x times 2, so negative 2 times 2 is negative 4, and then we write down the x value. Okay, and now this would be our simplified expression. This I wouldn't be able to solve, but what we started with is factored, okay, because we have two sets of brackets. It's that factored form we looked at in Unit 3. Now the reverse of going from the simplified to this bracketed form is called common factoring. Now what we're going to look at, if you look at the example we just did, both of these two terms have an x in common, and if we look at the coefficients, both of them have a common factor of negative 2. So the whole process of common factoring is finding your greatest common factor and then dividing it out. So let's try an example. Okay, our first step, determine the greatest common factor, or your GCF for short form. Okay, now in order to do that, you're going to look at the coefficients first. Okay, just find a common factor between the numbers. And once you do that, then you're going to look at the variables. And you're just going to take the smallest variable. Okay. So take smallest exponent. Now let's try that for this example. I'm going to figure out what my greatest common factor is. So I look at the 12 and the 18, and I try to think of, okay, what's the largest number that goes into 12 and 18? Well, that's going to be 6. So that's the coefficient out of the way. Now I look at the variables. I have x to the power of 5, and I have x to the power of 3. So the first term has 5 x's in it, the second term has 3. The lowest number of x's I can take out are 3, so my greatest common factor would be 6x cubed. Now, once we find the greatest common factor, our second step is to divide whatever polynomial we have by that greatest common factor. Okay, and whatever you get, that's going to give you the quotient. So I'm going to divide each of these by 6x cubed. Now, when you write out your final answer, you're going to write equals the greatest common factor. So what you divided out, you're going to put outside the bracket. And when you open up your bracket, you're going to put your quotient. So 12 divided by 6 is 2. X to the 5 divided by x to the 3 is x squared. Remember those exponent rules from grade 9. When you're dividing terms with the same base, you subtract the exponents. So 5 minus 3 is 2. The x stays the same. If I go to the next one, 18 divided by 6 is 3. And then x cubed divided by x cubed, I'm dividing the same thing by itself. That's gone. And that would be my final answer. So when you write your final answer, it's going to be the greatest common factor times that quotient from above. Okay, and that's it. So there's your GCF, and there's that quotient. And this we would be able to solve, but we'll get into that later on. Okay, before we move on to more common factoring examples, just want to emphasize the difference between factoring and simplifying. So when you're simplifying, you're using the rules of algebra to remove the brackets. Okay, you want to get rid of them altogether. Okay, so remove the brackets and collect like terms if you can. So you'd use distributive law from grade 9 or FOIL that we learned in the last unit. So if they told me simplify 3x times 2x minus 5, I want to get rid of those brackets. So I'm going to distribute that 3x in. So that's going to look like 3x times 2x is 6x squared. 3x times negative 5 is negative 15x. And now that's simplified. There are no like terms to collect. Factoring, you're using your rules of algebra to write your expression as a product of two or more factors. That's when those brackets come in. We want to introduce the brackets for factoring. So it's a product of two or more brackets. Okay, so that's when we're going to find that greatest common factor. So this is the same expression we just came up with. So the GCF would be the 3x, sorry. And then when we divide out the 3x, we'd get 2x minus 5. Now I just went quickly because I knew they were the same expression. Let's actually try another example of common factoring. I have negative 16x squared minus 8x. Now I want you to highlight the following. If the coefficient in the first term is negative, then the negative should be factored out with the greatest common factor. Okay, so over here, when I'm finding my greatest common factor, I'm going to include the negative no matter what. Now I look at 16 and 8. What's the common factor between that? Well, I can definitely factor out an 8. Between x squared and x, 2x's versus 1x, I can only factor out 1x. And now I'm going to divide each of these terms by negative 8x. When I write my factored equation, I put the greatest common factor out in front, and then I'm going to write the quotient for when I do the division. So negative 16 divided by negative 8 is now positive 2. X squared divided by x, there's just 1x left. And then negative 8 divided by negative 8 is positive 1. X divided by x is just 1. So we just leave it like this. Make sure it looks like you're dividing the same term by itself. Don't say it disappears. You have to write that plus 1. Because what you should be thinking is, if I were to redistribute that negative 8x in, will I get my starting equation? If you don't include the plus 1, there's no way you're going to get two terms. Okay, let's try a few more examples. Okay, so for 20x squared minus 12x, I want you to think of what that greatest common factor is. So pause the video, try to think of it on your own. So your greatest common factor here should be 4x. So that's what we're going to divide everything by. And when we divide it out, make sure we write the greatest common factor out front. And now I want you to do the division on your own and pause the video. So 20x squared divided by 4x, I hope you got 5x. Negative 12x divided by 4, negative 3. And that would be your common factored form. Let's try example 2. Now here we have a trinomial. Okay, there are 3 terms. I look at the negative. It starts with a negative, so I know my greatest common factor is going to have a negative with it. Now I look at 9, 6, 15. My greatest common factor is going to be a 3. Now I have 3 terms. They don't all have an x in common. That constant doesn't have an x attached to it, so I cannot factor out a variable in this case, and that's okay. So I'm going to divide everything just by negative 3. So when I write my final answer, I'm going to put my greatest common factor out in front, and then negative 9x squared divided by negative 3 is 3x squared. 6x divided by negative 3 is negative 2x. And then 15 divided by 3 is negative 5. And again, if you're not sure if you did it correctly, distribute that negative 3 back into your expression and see if you get the start. Okay, number 3 and 4 both have decimals in them. Now, if you have a decimal, sometimes that starting coefficient, you can factor it out from both terms. So I'm going to do a little check. 24.5 divided by 4.9. Will that give me a whole number? It does. It's 5. So my greatest common factor, well, first of all, it's going to be negative because the coefficient at the start is negative. Then we have the 4.9, and now I look at my variable. I have an x squared and an x, so I can definitely take out one of the x's. So now I'm going to show my division, and then I'm going to write my factored form. I put that greatest common factor out in front, and now negative 4.9 divided by negative 4.9 is 1, so the coefficient is 1. X squared divided by x is just an x. Negative 24.5 divided by negative 4.9 is going to be positive 5. And then, sorry, you're dividing out the x's as well, so you're just left with positive 5 at the end. I want you to try that last one on your own, so pause the video and then check it. Okay, so for number 4, your greatest common factor should have been 0.5x, and when we divide it out, you're going to get x plus 12 for your quotient. And that's it for common factoring. Check the coefficient for the greatest common factor, check the variables, just take the lowest variable or the lowest exponent. If all your terms don't have a variable in common, don't factor out the variable. And then you're just going to write that greatest common factor out in front, and then your brackets, it's going to be the quotient. So you're going to divide every term by that greatest common factor.